Hi, and welcome to this third video of the series of how to use TouchOSC with SonicPi. I've got the resolution screen set a bit high here so you can see the entire SonicPi screen, which I've got in this region here. On the top right, I've got an image of my iPad, and you can see the layout which we made last time with the two buttons on it, the push button, the toggle button, and the slider in the center. The program running down at the bottom right is a program called Audio Hijack, which is being used to mix together the audio from my microphone on the MacBook Pro and the output of SonicPi, so they can both be recorded by the software which is videoing the screen. So one of the things I said in the previous video was that it was very easy to find out the IP address of your machine which is running SonicPi. If you come up to the preferences and click on the I/O tab, it will list first of all the MIDI ports which you can see, and although we're not using it in this program, you can see TouchOSC bridge that we talked about in the previous video, which we would need if we were going to use MIDI input from the iPad if it was using a wireless connection. Also, one other important thing to set here is on the right hand side we have to turn on two little ticks here, one to enable the OSC server so that SonicPi can receive OSC messages, and secondly so that it can receive them from a remote machine like my iPad. For safety reasons, you have to actually turn that one on, because obviously if you can send OSC messages from external IPs, there is the potential for nasty things to get into your SonicPi, though it's hardly likely if you're actually using the program at this stage and you're working on a local intranet. But finally, you can also see the local IP address of my Mac here, which is 192.168.1128, and if we go back to the setup on the iPad, you can see that the OSC information is that the host is on 192.168.1128, and that's where we're sending the messages, which are going to actually go to port 4559. And if we look back at the Mac, you can see that it also says that it's listening for OSC messages on port 4559. So that's how you actually set things up so that they can go and receive messages from the TouchOSC interface. But you also remember that on this screen we showed that it was possible to have incoming OSC messages going to port 9000, which was the default which is set up there. And if we come back here, if we've just been playing around with the program, say doing things like this, and it's left in that state, then it'd be nice to actually initialize things when we start running the program. And to do that, we want to be able to put the slider back in the middle, and we want to be able to turn off the toggle button. Obviously this one doesn't matter because it only remains in the on state for as long as you are pushing it. When you take your finger off, it goes off again. So how can we do that? Well, that's done by sending two OSC messages out from SonicPi rather than into it. And we do that, we can use the OSC_send message, and that is followed by an IP address of where we want to send the OSC message, which is the address of our iPad. You can see, if I come up here again, the local IP address, the bottom line, top right on the screen over here, is 192.168.1240, which is what we've got set up here. You can see it's also going to send to port 9000, and it's going to send to the address /test/fader1. And that was the address we set up for the slider in our program, the slider which is here. And what we're going to do is to send a message to it saying set its value to 0. And you remember we set up the slider so that it went from -1 to +1, so 0 is going to be in the middle, which is where we want it to be. And then we have another OSC send to the same address and port, this time going to the OSC address /test/toggle1. That's our toggle switch on the right hand side, and we're setting its value to 0, which means we're going to turn it off. So what I'm going to do is simply to run the program, and you'll see the slider will move to the center and the toggle switch will go off, and there will also be some information which appears in this section of the screen and down at the bottom, which I'll discuss when we've done it. So here goes 3, 2, 1, go. And you can see in the middle of the screen here OSC 192.168.1.249,000 sending that information and sending the information for the toggle switch. And you can see, if you look at the picture up here, that the slider has gone to the middle and also that the toggle switch is now off. So that explains that section. Excuse my cough. You'll notice also I put a little sleep, 0.2 seconds, just to allow that to settle before we have the main live loops coming into action a bit further down the page. Now, we're also using a new feature in SonicPi 3, which is the fact that if you want to pass information from one live loop to another, or one program structure to another in SonicPi, the preferred way to do it now is to use the set and get commands. What these do is to effectively send event signals which store values in the timeline with a given name to get it back again, and we can then get it back from any part of the program, and it simply gets rid of any confusion about what's changing values of where, and allows this passing seamlessly. We're going to use a variable called trans, which I'm just setting to have an initial value of 0 here, and we'll come back to that further on. But let's look at the first live loop here, which is the one to do with the button, which is in a way the simplest one to deal with. I've called it live loop B1, and the next line says use real time. As you're probably aware, SonicPi uses a schedule ahead time which allows things to happen before they're actually sent to the sound output section, the SC synth. And in this particular case, we want a very rapid response, so we tell it to override that and use real time. And you'll see I put that in each of the 3 live loops which we've got on this page. Then the way you get the interaction with the OSC signal is that this live loop is going to wait for a sync signal, and the sync signal is given in the 3rd line here, and I've got a line that says B equals sync, and then inside speech marks /OSC/test/push1. Now you'll remember that when we set up the editor page in for TouchOSC, that the OSC address we gave to the push button was /test/push1. /test was the name I'd given to the page. We've only got one page here, and /push1 was the left hand of the 2 buttons on the screen. But here we've got it looking for an address /OSC/test/push1, and that's because SonicPi always prepends or puts at the beginning of any incoming OSC message the character /OSC. It's just so that in the queue log down at the bottom of the screen down here, you can tell the source of where messages are coming from. If they start off /OSC, they're external OSC messages. If they have something like /live_loop, that's actually the automatic queue which is sent at the beginning of the live loop when it starts a new cycle. It's true of any live loop unless you turn it off, as is /live_loop slider for the 2nd live loop here, and /live_loop toggle for the 3rd one down here. So we can tell which of these is being caused at different times. Notice also that the set command effectively sends a cue to store something in the timeline, and it's going to store the trans variable there, which we saw in the first line of the program up at the top. Don't worry too much about that if you don't follow that particular bit at the moment, but it's important to see that we are looking for a message /OSC/test/push1, and we get that when we interact with the left-hand push button here by pushing it. And if I do so, let's see what happens. Do it again. Each time I push it, I get a series of notes being played, and if we look at this live loop, we can see how that works. When we push the push button, it generates a cue, and it puts the value of the push button into B0. This is actually a list because there may be more than one parameter being set. Some of the more complicated things you can send might send 2 or 3 in one OSC message. So B square bracket 0 is the first element of this list, and what we're going to do is to print its state on the screen. And you can see that that's happened down here, but button 1 is 1. Now, if we press that, you can see it goes to 1. When I let go, it prints button 1 is 0, just down here on the screen, which you can see there and there in the log there. And if you look down, you can see the corresponding entries in the cue log. OSC test push 1 is 1 when it's pushed there, and OSC test push 1 is 0 when it's released there. So that's how you actually start things go. Now, we only want to play the notes when the push button is actually pushed, in other words, when its value is 1. So I've got a conditional in here that says if B0 is greater than 0, then that's okay, it's pushed, carry on. And what it does is to select a synth, I've used the try synth, and then to go around a loop 10 times, simply playing a note chosen at random from the E3 minor pentatonic scale. Nothing magical about that, it's just a way to generate some notes, and they're quite short. I've released them in 0.1 seconds, slept for 0.1 seconds and gone back and done that group 10 times. So that's how you get the 10 notes when I do this. And they're different each time because they're chosen at random, as you can see. So that's how we have a simple push button and how we can interact with it. Let's now look at the slider, which is obviously here in the middle. And here we have a live loop slider. And what that's going to do is, in the same way as for the push button, it's going to look for an OSC address. Remember, we sent out /test/fader1. So what we will actually be looking to sync to is /OSC/test/fader1. And one useful tip is when you are putting these in, if I just get rid of that for a minute, provided you leave a space before sync, when you get there and you put a space bar in there, you get a list of all the recent cues which have been generated in the cue log, and it means you can go down and choose the one you want without actually having to type it out. That's the one we want, OSC test fader 1. So I simply click on that, and it's typed it in for me. So if you've got a complicated address, that's a very useful tip for putting that in. Now, it's going to put on the screen the value of the slider. Now, in this case, remember, it's not an integer. It's going to go from -1 continuously up to +1, depending upon the slider position. And all we're going to do is to store that position in the variable trans that we initialized as 0 right up at the top. And because I want to be able to use the slider to move the tone of a note which we're going to generate up or down an octave, I'm simply going to multiply the value by 12 before we store it. Because if B0 is going to go from -1 to +1, that means that trans will go from -12 up to +12, and that's where that goes. Now we can see that in operation. If I move the slider up and down, you can see that every time that loop is triggered, and it will be triggered whenever there is an OSC message received, and that will happen when the slider is moved, and you can see the values being printed on the screen there. It's now -0.4. If I put it right down at the bottom, it's -1, and I put it right up at the top, it is +1. And the corresponding values of trans will be changed from -12 up to +12. So that's that loop. Now the third one is a bit more complicated simply because of what I'm doing. It's actually no more complicated as far as the OSC messaging is concerned than the one we did for the push button. The only difference we have is that we're syncing on OSC test toggle 1. That was the name of our toggle switch. We didn't change it from the default which was given. We could have done, but we didn't. And we're simply going to put its value on the screen. It shall be in the variable b square brackets 0 square brackets. And now there's two possibilities. If the button is on, then b0 is going to be bigger than 0. It's actually 1. And what we want to do in that case is to start a note going. And I'm going to start a very long note. I'm going to use again the try synth, and I'm going to start a note playing and keep a reference to it in the variable x. Now what I'm going to do is to actually control this note, to control its frequency as it plays by using the slider. And if you want to follow further how this is done, look at the control section in the help tutorial. If I come down here and we switch to tutorial and we go up here, I think it's about section, where are we? Lost it. Here we are, section 7. This is all about controlling running synths. And you can see some information about it here, which you may find useful to refer to in your own time a bit later on. So we're starting off playing a note which is going to have a value starting at C4, but with adding on to the top of that the current value of the trans variable. Now because we're adding these two together, I need to turn the note bit into a number. That's why I've said note open brackets colon C4, and then adding to that get colon trans. That simply goes to where trans is stored and gets its current value. So this will give us something between the pitch of a C4 plus or minus 12, depending upon what the value of trans is. In other words, up or down an octave. And we're simply going to say sustain that note for 1,000 seconds. So that note, if it did nothing else, would go on for 1,000 seconds. In fact, it won't, because we'll see what happens in a minute. Because I want to be able to do things to that note, I'm then going to store the value x in a variable colon x, which is stored by using the set function. And now this is where we get something which is a bit unusual. We're going to have an in thread in the middle of our live loop here, which is going to contain a continuous loop that's going to run indefinitely once we start the live loop. And what this is going to do is to control the value of the pitch of the note by using the stored trans value. And it's going to then alter it whenever that value changes by sliding we've got a little spelling mistake there. Let's just change that while we're here. That's better. My typing is not the best. It's going to change this by controlling the value that we stored, which is x, and it's going to control the note, and it's going to set the note to the note value of C4 plus whatever it currently gets from trans. And it's going to change the note over 1/10 of a second if the value in trans is different from what it was before. It'll then wait for a tenth of a second and it'll go round that loop again. So continuously it's going to change the pitch of the note as the slider moves up and down. Now, if we haven't got the note pressed, and obviously we turned it off, it's going to say otherwise, control the same note and set its amplitude to 0 over a tenth of a second. Otherwise, fade it out very rapidly, wait for a tenth of a second, and then kill that note, stop it from running. You can, if you've got a reference to a running synth, you can kill it using the kill command. And that means we've stopped it until we restart it again. So I've said quite a lot of that, but I think if you see it in operation, you'll see how things work. Let's set the slider roughly back to the middle and turn the note on. And as we expected, it says toggle is equal to 1. So in the loop that we've just been discussing, we've chosen the synth, we started playing, and we're now sitting in this loop. Remember, the live loop still runs because this is working in a thread, so it's working independently, effectively, of the rest of the live loop. And we can now move the slider up and down, up to the top, and trans gets higher. It's going to be 12 now, as the slider is 1, back to the middle, down to the bottom, it's minus 12, back to the middle again. We'll leave it down there, and we can simply turn the note off, like that. That's killed that note that was lasting for 1,000 seconds. You can see it says killing sound number 2876. If we start another sound, it'll start in the same pitch. If we kill it again, that will kill note 2877. It allocated the next reference to it because it was the next note which was created. And so we can simply turn these on and off whenever we want, at whatever frequency we want, and move between them. So it shows very clearly a nice way of controlling SonicPi using TouchOSC, and all the time the other 12 notes are working independently. We can have both running at the same time. We can even be changing the notes as this runs, because the live loops are running together and they will work alongside each other. So that gives us the whole program. I hope that you've found it an interesting series to watch and that you'll be encouraged to get hold of TouchOSC. It's a very modestly priced program and it is so versatile. I have done, for example, layouts. Let me just show you one or two of them. If we come down here, we can't actually use them all, so we haven't got them all on. This was one I used which would do a multiphonic synthesizer which I could play using the keyboard. I could play up to 8 notes simultaneously and they'd last as long as the MIDI note was played, a bit like we've just seen here. Let's look at another one. Go back to the list. Here is the most complicated one I've done, and this was a MIDI controller where I could adjust such things as the attack, sustain, release times, volumes, G-verb, cutoff, and choose various synths along here and have all 16 MIDI channels which we choose. I could do pitch bend, things like this, and this one had 2 screens on it, and on the second screen I could adjust channel pan settings, and I could adjust, I could scale the ASR, the attack, sustain, release times for any particular channel with a scale factor here. So you can see that gives you an example of a more complicated screen which can be produced with this. And let's perhaps look at another one which I have also written up, which you'll be able to try out if I can work out where it is. It's a problem of having lots of these things. They get rather that one, I think. Yes, that is a simple keyboard which would play with 4 different synths which could be selected. I could change the volume, I could change the release time, and I could move the keyboard up and down an octave. And that, you can see, is not too dissimilar to what we've been using here. I'm sorry it's on the wrong way round, but on the screen, but that's because this was chosen for the landscape view. So I hope that gives you an idea of what can be done with this, and I hope you've enjoyed watching the video. Thank you very much for watching.